Good day, the moderator and the chairman of this session. My name is Ukekwe EC from the Department of Computer Science, UNN. I'm here to present a paper titled A Framework for Enhanced ATM Fraud Detection Using Customers' Behavioral Pattern. My colleagues are Nnakwuzie DN and Ezugwu OA. We know that ATM technology has improved our personal banking, especially as it concerns e-commerce and online transactions. And the ATM debit card literally represents virtual cash, which can be used for a wide variety of transactions such as transfer, withdrawal, checking of balance, and even payment of bills. An ATM debit card holder will need a personal identification number in order to withdraw money from the ATM machine. There are challenges associated with the use of ATM debit card. One of such challenges is fraud. In this paper, we have classified fraud into internet fraud and ATM machine fraud. Internet fraud has to do with online banking, while ATM machine fraud is associated with the use of ATM machine and transactions. The ATM machine fraud is our focus in this work. The two major fraud we are trying to address are stolen card fraud and cloned card fraud. There are efforts already in place at solving the fraud challenges in ATM. Bolton and Hand successfully used a peer group analysis tool to monitor and detect abnormal transactions. However, the research was solely based on the amount spent by the individual. They did not consider other variables. Abdullahi et al. Also proposed an algorithm that implements the thumbprint in order to improve ATM security. But this also requires a complete redesigning of the ATM machine, which wasn't cost effective. Chankwa and Pandi also recommended the use of OTP codes, but we know that OTP codes could be unreliable, especially in a weak network. Claes et al. Developed an algorithm for learning a cardholder's ATM behavior. But once again, the interpretation and prediction carried out in that work were not in real time. Based on this, there is need to develop a system that enhances the ATM security in real time. While the card user is making transactions, the system is verifying and validating the card user in the background. This is done in real time. How the ATM machine works. The ATM machine connects and communicates with the host processor, which is the server. The host processor communicates with the internet service provider, which provides the network for the ATM. Information provided by the cardholder are forwarded to the host processor and to the cardholder's bank. It is through this same means that the cardholder receives authorization and cash is dispensed. This is shown in figure 2. We can see the bank computer, the host computer, and the ATM interacting using the telephone network. In figure 3, we see the algorithmic operation of the ATM machine. The ATM card user inserts a card, enters PIN. A verification is done on the PIN. If the PIN is correct, the user proceeds with the transaction. If an attempt is made for more than 3 times, the transaction is terminated, either by blocking the card or seizing the card. Unfortunately, there is only one verification procedure in this existing process. The PIN is the only verification. As such, it is regarded as one-tier verification process. There is therefore need to enhance the one-tier verification using the behavioral pattern of the card user. This brings us to the enhanced system. The enhanced system occurs in real time and makes use of logistic regression to model two basic variables, the withdrawal amount and the geographical location. It is believed that ATM card users will only make use of the ATM machines within their geographical location. And income earners usually withdraw definite amounts, especially for salary earners. They cannot withdraw more than they earn. With these two variables, XI1, which is the withdrawal amount, which the ATM card user enters using the ATM keyboard, and XI2, which is the geographical location extracted from Google Map. Regression model proceeds. We also know that every ATM is uniquely numbered and identified in the hosting bank database. Because of this, it is easy for the geographical location to be matched and recognized using the existing data in the bank's database. And ATM machines within a certain geographical location are classified as being the same. For example, First Bank has 2 branches in Nsukka. If you are withdrawing from branch A or branch B, you are still regarded to be in the same geographical location. Of course, the geographical location and the withdrawal amounts are compared with previous transaction data using the logistic regression model. Transactions that are routine and predominant are classified as safe, while new transactions and less frequent transactions are classified as unsafe. The new transactions could be different. Transactions made on different locations, which has not been done before, or withdrawal amount which has not been or which doesn't exist in the database. The enhanced ATM transaction flow uses a 2-tier authentication, which are the existing authentication for a standard ATM already discussed in the previous slides. In addition to that, the real-time logistic results of the input instance of the cardholder, which we are actually proposing. The logistic model is given in equation 1. Y represents the transaction status, which is our focus. It could be safe or unsafe. XI1 is the previous withdrawal amount, while XI2 is the previous geographical location, all existing in the database. If the transaction is predicted as unsafe, then the second tier authentication is triggered so as to validate the card user. The verification can be a request for BVN, date of birth, or even test question, which is incorporated into the ATM form request when the user is registering. The transaction can also be said to be safe. When it is safe, there will be no need for extra verification. Figure 4 shows the implementation framework algorithm for enhanced ATM fraud detection system. You can clearly see that it is a modification of the first tier verification. The second tier immediately takes over after the first tier. The ATM card user enters an amount and the location is extracted from Google. The logistic regression takes over to determine whether that transaction is safe or unsafe. If it is an unsafe transaction, there will be need for extra verification. If it is a safe transaction, there will be no need, but payments will simply be authorized. This way, the existing first-tier verification process of the ATM is enhanced, making it difficult for hackers to gauge what the user has in his database. These things that the user has are what determines the behavior of the cardholder. Figure 5 also shows the implementation framework architecture for the ATM system. We have the user making requests and receiving responses. The response can be error, response can be form of entering extra verification. The response can also be a successful transaction. You can see the logistic regression, detecting safe and unsafe transactions. Summary and conclusion. In this work, we have seen that we've been able to enhance the existing first-tier authentication process of the ATM using the logistic regression model. The model makes use of two predictor variables, which are withdrawal amount and geographical location. We have also seen the implementation algorithm and the architecture. This being a framework, it is believed that if the algorithm and architecture are fully implemented, developed, and deployed, we know that the ATM fraud will reduce, especially the stolen card fraud and the cloned card fraud. This will benefit the users and the host banks. Thank you for your audience.